Hearing about an immutable database. Come to Nostokolo. They can hear, right? Okay. Hey, friends. It was a cold, dark night in New York City. Rich Hickey pondered in his study, frustrated with complexity, mutated state, never-ending, inherited boilerplate. He suspected there could be a better way, without sacrificing power, focus, or mutating state. He admired functional programming philosophies, but he was interested if they could be applied more practically. Because humans are chaotic, and our data, it reflects that. Sequential data, linked lists, good in classrooms, great in theory. But for production systems, associative structures, hash maps, arrays, Rich suspected perhaps this was the way. Okay, that was fun, right? This is a fun talk, so we're having fun. So something I noticed is that my mic keeps dropping, is something that I noticed. Okay, I didn't mean to sound so mad. Okay, so something I noticed that when I speak about these concepts of simplicity and complexity, we all agree that complexity is the enemy, right? We hate it. But are we all working with the same definition? So to understand complexity, let's consider the opposite. Let's consider simplicity. So I told you the origin story of Rich Hickey, the creator of Clojure, the programming language, which we'll hear about a little bit today. And if ideas make sense to you, I encourage you to check out his talk, Simple Made Easy, because this is a very distilled, fun version of a lot of those concepts. Because there's a reason you've probably lost at least one of your friends to the parentheses, never to be seen again. So, ¿qué es simple? Simple means not interleaved. Simple no está entrelazado. The simplicity of a thing can be objectively observed. Simple is about separation. Simple is about cardinality. Simple things are independent from one another. Simple things are unrelated to one another. Simple things are composable. And although often confused, simple is not easy. The easiness of a thing is all relative. It's dependent on a practitioner's previous experiences and things such as their competence level, their working brain load, their existing mental models, and their chunks of expertise. What's easy for you may not be easy for me, and vice versa. So we can never create anything and just say, it's easy. That's a lie. But we can create things that are simple. Because in terms of software, simple is not about fewer lines of code, although we do have fewer lines of code. Simple is about non-interleaved concepts. But why do we care? Because when data and behavior are entangled, the truth becomes hidden, and correctness becomes invisible. So regardless of your level of experience, whether you're an L10 distinguished engineer or you're a junior dev, with no correctness, there is no reason. There's no ability to think of anything. If in a black box, no caja negra, if there's no truth, there is no correct answer. Complexity. ¿Qué es complejo? Complexity is the entanglement of ideas, states, or time. La complejidad es una mezcla de ideas, estados, o tiempo. Complexity is dependencies. Complexity is what happens when things that should be separated become braided and entangled. A human's cognitive load, their ability to reason, is only 7 plus or minus 2. So the more complex something is, the riskier it is. Complexity increases the surface area for failures. Complexity is anything related to the structure of your system that makes it hard to know what it's doing. And you want to know one of the biggest culprits of complexity? Mutability. So I came across a post recently where somebody was asking why Clojure has so many abandoned libraries. No recent commits, no major updates. They were confused. They weren't sure whether to use it or not. And the best response was, they're not abandoned. They're just done. Finito. So what is Clojure? I've said that word a couple times. It's a general purpose, open source programming language, and it's hosted on the JVM. We also have implementations that are hosted on JavaScript. It's a Lisp, and it's designed for production systems, sistemas de producción. And simplicity isn't a feature, it's the entire premise. And as a result of it, our libraries and our tools tend to be small, composable, and mostly complete. So I'm going to give you a minute to look at this. This is a code retention diagram. It shows how much code from a given point in time is still in use at a later date. And this is what long-term reliability looks like. It's a layer cake of compatibility. Compare that to the constant erosion that you see in other ecosystems. I feel like so many people have like this Stockholm syndrome when it comes to complexity in your systems. You're so used to constant changes, a new version, a new breaking API, another rewrite, another tool, another SaaS, more logs, more metrics, more alerts, more vigilance required. And that's more money for the people in this room making those tools, right? But what if we just built things with the goal of being done? This diagram shows what happens when you design for done. Your mutable system is lying to you, and it doesn't have to be that way. Every update is a lie that's rewriting the past. Every mutable value hides important context. And most systems today change and they lose important data by default. And then we create external tooling, logs and metrics and dashboards to pretend otherwise. But who here has spent time debugging something only to realize that you were asking the wrong question the entire time? Okay, good, because I was like, oh, wow, y'all are perfect. Okay. And it's because mutable systems don't have truth. Mutable systems have guesswork. What happened turns into a mystery. Git blame, stack scrollback, Slack scrollback, maybe luck. Because mutable state is one of the biggest sources of entanglement. It introduces time-based coupling, race conditions, fragile tests, loss history. And most databases don't remember the past. They just reflect the current state. So we build these brittle observability layers to try and reconstruct what happened and rebuild it. But what if your system just never forgot? So Datomic was created by the same team behind Clojure, and it shares the same core values of power, focus, and simplicity. And both were designed very intentionally for long-term correctness, remember, for production systems. It's time-aware, it's immutable, and it's designed to preserve truth. We store facts, not state. Nothing is ever overwritten, and every change is additive. And like Clojure, Datomic makes the correctness the default, not an afterthought. Imagine a database that works like Git for your data. And just like Git tracks every version of your code and lets you go back in time or explore branches, Datomic treats the entire database as an immutable value that grows over time. Every change is a new fact appended, added to the history, not a destructive rebase overwrite. Because most databases rewrite and rebase your history by default. They're like whiteboards. You erase and rewrite. Datomic is different. Datomic is like a ledger. You add new entries, you append, and you never lose what came before. In a traditional database, you would mutate, well, update rows. Jordan's hair color changed. In Datomic, built into our data model, you add a new fact. As of today, Jordan has pink hair. You don't destroy the old information, you just give new information that says that the old one is no longer current. So Datomic, the database itself, is an immutable value, like a snapshot of the world at a point in time. And when you query it, you're asking a question about that value. And to change it, you add, you append, you add new facts, and the system constructs a new value representing this updated world. We call this concept database as a value, and it's really powerful. It's also really hard to explain. I hope I'm doing it justice. But it allows for time travel. You can query the state at any point in time. What did something look like at this point in time? It's debuggable, so it's kind of like many people are familiar with like a Python debugger. You know that feeling? In Clojure, we have the REPL. that quick feedback loop, or if you do JavaScript, how you can have the console, that very quick, we have that built into Clojure. And then with immutable data, we have that built into Datomic. You can audit everything that ever happened. The debugging story is really great. It's very clear. It's reproducible. Queries are deterministic over historical values. It's composable. You can pass the database value to a function just like any other data, because code is data and data is code, as far as we're concerned. I'm giving a minute to process. So what is this? This is the Stack Overflow survey question that pretty much sums up the justification of my paycheck. And who signs my paycheck? I will tell you in just a moment. So we see here that Datomic is the most loved, but the least known, all the way at the bottom, 0.3, great. And fun fact, Clojure is always one of the highest paid and most loved, if you're interested in that data point. But okay, why? How do we get here? And it's because in our over a decade of existing, we've never really made it a goal to have the most users. Like, we exist to solve a couple of problems typically experienced by senior backend engineers and architects and experienced in domains such as fintech and health records. Complex domains with complex compliance and complex regulations where you really can't afford to lose your things. And unfortunately, unlike in the safe walls of a classroom, we can't escape complexity in our domain. So I told you I'd say who's funding this mission. So in Portuguese, nu means naked, and so I will be naked and transparent with you. I work on the Datomic team, and in 2020, Nubank, a digital bank in Latin America, acquired us, and so I am indeed being paid to be here. And on other slides, I have all sorts of numbers meant to impress you, but this is not a vendor pitch. And actually, Datomic is free to use. And we only want you if what I'm saying resonates. My metrics have to do with raising awareness and nurturing an existing community that's pretty happy, and letting people who are experiencing certain kinds of problems know that we exist and that we're production ready. And so you can consider Clojure or Datomic in your solutions in the future if it's appropriate. So here, I guess I've done that. So here I think I'm done. We will do the takeaways. Simple is not interleaved. Mutability is complex, and complexity causes failures. Correctness can live in your data model. All right, we'll do a little bit of a Q&A, and I'm actually going to have my colleague Aldo join me in case there are questions that I can't answer, because I'm not a super expert. But he's been at Nubank for 5 years, so he's worked on pretty much every single part of the stack, right? Yeah. And so I do need, what? Oh, yeah, woo!